Okay, ever get that feeling
Mm,
where your computer just grinds to a halt, like it's suddenly stuck in molasses, and you have absolutely no clue what's going on?
yeah.
That's what we're going deep on today.
Oh, yeah.
On the deep dive, we're tackling Linux performance troubleshooting head on,
Mm.
using these really cool hands-on demos from a Grobble Dev YouTube video. It's called Linux Performance Troubleshooting Demos.
We're not just skimming the surface here, right? We want to get down to the nuts and bolts, give you the tools to actually diagnose those pesky problems.
Exactly, like actually figure out why your Linux system is acting up.
That's right.
So we've pulled out the most useful techniques and those aha moments from the demos
Yep.
to really help you understand what might be slowing you down.
Yeah.
We're going to focus on 3 common issues from the video.
Okay.
First up, that slow creeping latency
Yeah.
where your app just gets laggier and laggier.
Yep.
Then the oh no moment when your app just takes forever to do anything. And finally, the real head scratcher when your CPU is maxing out, but you can't tell what's causing it.
Right.
And like the video shows, the first thing you do is turn to those classic commands, top and vmstat.
Yeah.
Those give you that first glance at what's happening under the hood.
Right. That initial overview.
All right, let's jump into that first scenario, the increased latency. The user just notices things are slower, you know?
Mm.
And in the demo, the first thing they do is run top.
Yeah.
Now, top gives you this real-time view of all the processes running on your system and what resources they're using.
Exactly. It's a dynamic snapshot of your system's health right there in the terminal.
Right. And in this specific case, the demo focuses on 3 key metrics from top.
Okay.
They see very low user space CPU, only 0.4%.
Right.
But then there's significantly higher system space CPU at 38.5%, and a lot of idle CPU, like 39.2%.
That's interesting.
And that high idle CPU is the first big clue,
Right.
right? Because as they point out in the video, if your CPU is mostly just sitting there, well, the bottleneck probably isn't a lack of processing power.
Yeah. You got to look somewhere else.
Exactly. It's not the CPU itself.
Right. So what's next?
So the next step in the demo is to use vmstat1. That 1 means it's going to give you updates every second, which is really helpful to catch those little bursts of activity.
Makes sense. So what's vmstat telling us?
vmstat gives you even more system info. In the video, they pay attention to the war column, which shows how many processes are actively running or waiting to run on the CPU.
Okay.
If that number gets really high, like more than the number of CPU cores you have, that's a sign of CPU overload. But in the demo, those values stayed pretty low.
Right. Right. So not a CPU problem there.
No. And the memory part of vmstat looked good too. Plenty of free memory, buffer, cache, all above 0.
Yeah.
And most importantly, the swap values were 0.
Zero swap. That's always a good sign.
Right. Because, and the video explains this well, when your system starts using swap, things get really slow. Because accessing data on the hard drive is way, way slower than
I don't know,
RAM.
orders of magnitude slower.
So that's definitely something you want to avoid. Then, the demo looks at the CPU stuff in vmstat, user system, idle, wait IO, and stolen.
Okay. And what did those show?
They saw that same pattern from top high system time and low user time. So again, it's not like the CPU is overwhelmed with running the application code itself. But the weird thing was this really high wait IO, like around 17%.
That's a pretty big red flag, isn't it?
Yeah, because it means the CPU is spending a bunch of time just waiting for the disk to do something.
Right. Makes sense.
It's like the operating system can easily stop an app that's using too much CPU to give other apps a chance, right?
Uh-huh.
But when it's waiting for the disk, it's stuck.
I see. Yeah.
It can't just interrupt that. So
Oh.
everything gets backed up. Then the video briefly mentions vmstat, which is another tool for looking at CPU usage, but this time on a per-core basis.
Right. Right. Makes sense.
So you can see if maybe one core is getting hammered while others are just chilling, which might mean there's an issue with like a single-threaded application. But in this case, all the action was happening on one core anyway, so it wasn't super relevant.
Got it. But still a good tool to know about.
Totally. Then they really dug into the disk situation using iostat.
Okay. That's where things get interesting.
The main thing they looked at was %till, which is the percentage of time the disk is busy with requests. And what did they find? A huge number, 78%.
Whoa, that's high.
Way over that 60% threshold where things start getting really slow.
It's like a traffic jam on the highway.
Exactly. The disk just can't keep up with all the requests coming in.
And as the video points out, the kernel handles CPU and disk I/O differently. It's easy to stop a CPU-bound process, but once a disk operation starts, it's way harder to interrupt. So that can lead to a huge bottleneck. And just to be thorough, the demo also checked the network using the SAR command,
Oh, right.
and they didn't find any issues there.
So no network problems.
Yep.
So in that first scenario, the problem was the disk. We saw how they started with top for a general overview, then used vmstat to look closer at CPU, memory, and that crucial I/O wait time. And finally, they confirmed the disk bottleneck with iostat.
A classic case of detective work.
Totally. And that leads us to the second demo, where the user reports that their application is just taking forever.
Oof, that sounds painful.
Definitely more dramatic than just a bit of lag.
Yeah.
And once again, the first command they use is vmstat to get that snapshot of what's going on.
Okay, and what does vmstat tell us this time?
Well, first of all, the rack column was super low, so it wasn't a bunch of processes all waiting for the CPU.
Right.
Memory looked good too. Free memory, buffer, cache, all plenty, and no swap usage.
Good sign so far.
But then they looked at the CPU stats, and that's where things got weird. Basically 0 idle time.
Huh.
And both user time and system time were through the roof, like 55% user and 45% system.
So the CPU is definitely working hard.
Oh, yeah, super hard. But not on, like, processing the application's actual code.
Right, because the system time is so high.
Exactly. It means the kernel is doing a ton of work on behalf of the app.
Okay. Like what kind of work?
Like handling system calls, managing memory, dealing with those disk requests we talked about. So this is a clue that something's off with how the app is interacting with the kernel.
Interesting.
And to double check, they ran vmstat, which confirmed those high user and system times across all the CPU cores.
So it's not just one core that's struggling.
Nope, they're all busy.
Yeah.
So the next question is, which process is the culprit?
Right.
And that's where PIDstat comes in. In the demo, PIDstat clearly shows that a process called lab-oo3 is hogging almost all the CPU resources.
So they found the bad guy. But why is it using so much CPU?
Right, that's the next puzzle. And the demo goes through this really nice process of elimination.
Okay.
They start by checking the disk with iostat, but disk utilization was super low and wait times were fine.
So not the disk?
Nope. Then they check the network with SAR. Again, no problems there.
So what else could it be?
That's where they bring out the big guns, Strace. Strace, that's a powerful tool.
It is. Strace lets you see all the system calls a process is making to the kernel. It's like spying on the app's conversation with the operating system.
I like that analogy.
So they ran Strace with a couple of flags, desc to show the most frequent system calls, and desc to add timestamps.
Okay.
And what did they find? The application was stuck in a loop, calling the read system call over and over and over.
Oh.
But here's the kicker. It was asking for 0 bytes of data every time.
So it's like knocking on the kernel's door repeatedly, but not actually asking for anything.
Exactly. Just wasting the CPU's time. This is a classic programming error.
Yeah. Can definitely see how that would cause problems.
So in this second scenario, the steps were, first, vmstat to see that crazy high CPU usage.
Right.
Then PIDstat to identify the lab-oo3 process as the culprit. Then they ruled out disk and network issues. And finally, they used Strace to see those system calls and find the problematic loop.
A nice methodical approach.
Yep. It shows how important it is to have a bunch of different tools at your disposal.
Couldn't agree more. Now, ready for the final challenge? The mysterious CPU consumption.
Let's hear it.
This one starts with a pretty simple symptom. Something is using a lot of CPU, but it's not clear what.
Okay.
And as you might expect, they begin with top.
Makes sense.
And top does show high CPU utilization, like 90% user time and almost 10% system time. So the CPU is definitely working on something.
Right.
But here's the thing. Top doesn't show any single process that seems to be responsible.
That's strange.
The video points out that this is a limitation of top. Because it updates every few seconds, it can miss processes that start and finish really quickly.
Oh, I see. It's not capturing those fleeting processes.
Exactly. And they tried vmstat as well, hoping it would show which CPU core was being used the most, but no luck. Just confirmed the high CPU usage.
So back to square one.
Well, not quite. The next step is to rule out those usual suspects for high system time.
Okay.
First, they checked iostat for disk activity, but the disks were basically doing nothing.
Not the disk then.
Nope. Then they checked network I/O with SAR. Same story, no significant activity.
So not disk, not network. What's left?
That's when they turned to a more advanced tool, perf.
Perf, now we're talking.
Yeah, perf is this really powerful profiling tool for Linux.
I've heard of it.
The specific command they used was a bit long. It was perf record SF99 as AG, callgraph FP0 IIPD 1000.
Okay, that's a mouthful. What's it doing?
Let's break it down.
Right.
An SF99 means it's taking 99 samples of what the CPU is doing every second.
Okay.
A tera means it's profiling all the CPUs.
Uh-huh.
Tera is super important. It turns on call graph recording, which basically shows the chain of functions that are being executed. So you can see not just what's using the CPU, but how it got there.
That's really cool.
It is. And then call graph FP0IP is a specific method for doing that call graph recording. And finally, MATIZ 10,000 sets the recording time to 10 seconds.
Got it.
Oh, and the video makes a point of explaining why they use 99 hertz instead of a round number like 100. It's to avoid accidentally syncing the sampling with any processes that might be running at exactly 100 hertz, which could mess up the data.
Ah, that's clever.
So after perf record runs for those 10 seconds, you use perf report to analyze the results.
Okay.
And that's where the mystery is solved. Perf report showed that a whopping 82% of CPU time was spent in the checksum command.
So checksum was the culprit all along.
But why didn't top show it? The video explains that checksum is a super short-lived process running for just a few milliseconds.
Ah, so it was happening too fast for top to catch it.
Exactly. And the video mentions a few alternative tools that are better at catching these quick processes, like a top or using the perf tools exec or exec snoop utilities.
Good to know.
So the big takeaway from this third demo is that when you have high CPU usage but top isn't helping, you need those more powerful profiling tools.
Makes sense.
It's all about understanding the limitations of your tools and having a variety of options.
Absolutely. The right tool for the right job.
Exactly. So let's recap what we've learned from these 3 demos.
Okay.
We started with top and vmstat for that initial overview, then used mstat to look at CPU usage per core, iostat for disk bottlenecks, SAR for network issues, pidstat to find those resource hogging processes, and then the powerful strace to dive into system calls. And finally, perf, along with a top and those perf tools for catching those super fast processes.
That's a pretty comprehensive toolkit.
It is, and it shows that troubleshooting these Linux performance problems is like a detective investigation.
You got to follow the clues.
Exactly. Start with a general overview and then zoom in using more specific tools based on what you find.
That's a great way to put it. You know, while we've been talking about all these different troubleshooting scenarios, it really underscores how critical a solid IT infrastructure is. And that brings to mind our sponsor, Stonefly. They've been helping businesses with their IT needs for over 2 decades.
Yeah, Stonefly has a ton of experience.
But as a technical engineer there, I can tell you, they really get it. They understand the importance of performance, reliability, and data protection.
Absolutely. And one of their flagship solutions is the DR365V appliance, which is specifically designed for backup and disaster recovery.
Oh yeah, the DR365V.
A key feature of that appliance is immutable air-gapped backups.
Those are crucial, especially these days with ransomware and all that.
Totally. Immutability means that your data can't be changed or deleted even if someone gets into your system. And the air gap means there's a physical separation between your backup and your main system.
Like a real offline copy.
Yeah, that's your last line of defense. And the DR365V is more than just backup and DR. It can also handle site recovery, which is essential for minimizing downtime in case of a disaster.
Right, it's all about business continuity.
And Stonefly has this amazing offer right now, a 70 terabyte DR365V appliance that can scale up to 4 petabytes.
Wow, 4 petabytes.
I know, right? And it's got those immutable air-gapped backups, works with all the major backup software like Veeam, Rubrik, and Commvault. Plus, it's got their object lockdown technology for extra ransomware protection.
That's a serious piece of hardware.
It is. And all for just $7,995.
That's a steal. You know, if we connect this back to our performance troubleshooting talk, having a good backup and DR strategy, like what Stonefly offers, actually helps with overall performance.
How so?
Well, when you know your data is safe and secure, you can focus on optimizing your live systems without worrying about data loss. It just gives you that peace of mind and resilience that's essential for a high-performing infrastructure.
That makes a lot of sense. So if you're dealing with performance issues or just want to beef up your data protection, definitely check out Stonefly. You can find all the info on the DR365V and their other solutions at stonefly.com.
All right, as we wrap up our deep dive into Linux performance troubleshooting, we've seen how a structured approach, using the right tools and understanding those key system metrics, can turn a frustrating problem into a solvable one.
You're now equipped to gather those clues and get to the root cause of those performance issues. No more just staring at your computer in despair.
Exactly. Now you can take action. And that leads me to a final thought for you. Think about how quickly diagnosing and fixing these performance bottlenecks can impact not just individual apps, but your entire system.
Interesting.
What other hidden performance killers might be lurking in your infrastructure? And how can you use continuous monitoring and the right tools to find them before they cause problems?
Those are great questions to ponder.
It's a constantly evolving field, so stay curious and keep learning about these tools. That's the key to staying ahead of the curve.
Absolutely. Thanks for joining us on the deep dive. We'll catch you next time.
See that?